My dear students, again, this particular video is surely going to give you some 80 to 100 marks in just 10 to 20 minutes for sure. I have come up with almost some 20 easy kill concepts. What are easy kill concepts? When you receive your paper in the examination hall, by just looking at the paper, you'll find some concepts, right? Which does not need pen paper to solve. By just looking at the questions, you can do those questions. So I have come up with such 20 concepts, right? Which does not even require your pen and paper, and you can solve those questions in less than 10 seconds for sure. And these sort of questions do come in your examination. Almost 5 to 10 questions in chemistry will be there of such pattern, which I'm going to show you in the today's session. So first of all, identification of oxidizing and reducing agent. How do we get to know whether the substance is oxidizing agent, whether it's going to behave like reducing agent, or it can behave like oxidizing agent as well as a reducing agent? For example, you'll be given the question, what is H3PO4? Is it going to behave like oxidizing agent, reducing agent, or both? H2O2, is it going to behave like oxidizing, reducing, or both? HClO4, oxidizing, reducing, or both? What do you need to do? My dear students, whatever compound will be given to you, first of all, you will be calculating the oxidation state of the central atom. You'll be always calculating the oxidation state of central atom. For example, phosphorus here is in +5 oxidation state, oxygen here is in -1, this chlorine is in +7 oxidation state. So first step is to calculate the oxidation state of central atom. Now, remember, if the central atom is already in highest oxidation state, then it's going to behave like the oxidizing agent. If the central atom is already in lowest oxidation state, it's going to behave like the reducing agent. If the central atom is neither in highest nor in lowest, if it is in intermediate oxidation state, it's going to behave both oxidizing as well as a reducing agent. Now the central atom here is phosphorus, right? Right? Now, my dear students, what is the range of the oxidation state that phosphorus shows? Phosphorus shows the oxidation state from -3 to +5. -3 to +5. Similarly, oxygen, what is its range? Its range is -2 to +6. Similarly, chlorine, what is its range? Its range is -1 to +7. Do remember these ranges first of all. Here, phosphorus is already in highest oxidation state, right? That means it's going to behave like the oxidizing agent. Oxygen is neither in lowest nor in highest. It's in intermediate oxidation state. So it's going to behave both oxidizing as well as a reducing agent. Chlorine, +7. +7 is the highest oxidation state of chlorine. So chlorine is already in highest. So it's going to behave like the oxidizing agent. And remember, that particular compound in which the central atom will be in intermediate oxidation state, that particular compound also shows disproportionation as well. So there can be one more question asked. Which of the following compounds shows disproportionation? Remember, you just have to check the oxidation state of the central atom. If the central atom is in intermediate oxidation state, neither in highest nor in lowest, in intermediate, it can undergo disproportionation for sure. Now they can ask you the question, which of the following can undergo disproportionation? Here, this cannot undergo disproportion because this is in maximum. This cannot undergo, it's in maximum. This can undergo disproportionation because it is neither in minimum nor maximum. It is in intermediate. So it can undergo disproportionation. This can be one more question asked, right? Okay, moving on to the second concept. N factor of acids. Basically, they'll ask you to calculate equivalent mass of acids. And remember, equivalent mass is nothing but equivalent mass of the substance is molar mass divided by N factor. Now the point is, how do we calculate N factor of acids? N factor of acids is nothing but, that's called as basicity. And basicity you are going to define in two ways. Number of H positives and acid donates, or number of OH negatives and acid accepts. Number of H positives and acid donates, or number of OH negatives and acid accepts. That defines the basicity of the acid. And whatever is going to be the basicity of the acid, that's what you call as the N factor of the acid. Now remember one thing, guys. When one H positive combines with one OH negative, it leads to the formation of one water molecule. Similarly, if two H positives combine with two OH negatives, they'll form two water molecules. Now, for example, these are some questions. I have to calculate N factor of H2SO4 here as well as here. Okay. Now, first of all, look at the reaction. How many water molecules are formed? Two water molecules. Can I say two water molecules can be only formed if this would have given two H positives, this would have given two OH negatives, and they would have combined and formed two water molecules. Now, this acid is giving two H positives, and the number of H positives an acid gives, that defines its basicity, and whatever is the basicity of the acid, that's what you call as the N factor of the acid. If you look here, one water molecule is being formed. That means this acid would have given one H positive, right? And this base would have given one OH negative. They would have combined and formed one water molecule. So I would say this acid is giving one H positive, so its N factor here is going to be 1, right? Look at this one. This BOH whole thrice, this is called as boric acid. It's called as boric acid. Remember, it's a weak Lewis acid. It is a weak Lewis acid. Okay, now understand. How many OHs do you see here? 3. How many OH do you see here? 4. That means when boric acid was introduced in water, has it gained an OH negative? It has 3 OHs here. Here it has 4. That means when you have put it in water, it has gained 1 OH negative. And the number of OH negative an acid accepts, that defines its basicity, right? So it is accepting 1 OH negative. So its N factor is 1. And if you got their N factors, you can easily calculate their equivalent masses. How? Their molar mass divided by their N factor. H2SO4's molar mass is 98 grams divided by its N factor. 98 divided by N factor. Similarly, its molar mass divided by its N factor. You can calculate the equivalent mass of the substance, equivalent mass of the acid particularly. Similarly, N factor of the base. N factor of the base is what you call as acidity. Acidity you can define like this. Number of OH negatives a base donates or number of H positives the base accepts. For example, how many water molecules are formed here? 1, right? So that means this base would have given 1 OH negative and this acid would have given 1 H positive. They would have combined and formed 1 water molecule. So this base is giving 1 OH negative and the number of OH negatives the base gives, donates, that defines its N factor. So its N factor is 1. Similarly, 2 water molecules, that means its N factor here is 2. Perfect. Now look here, ammonia. Ammonia is the base. Perfect. When you are introducing this in water, it gets converted into NH4 positive. Over here, how many hydrogens do you see? 3. Over here, how many hydrogens do you see? 4. That means when ammonia was introduced in water, has it accepted 1 H positive? Yes. And the number of H positives a base accepts. The number of H positives a base accepts. That defines its acidity. And whatever is the acidity of the base, that's what you call its N factor. So its N factor is 1. If you got the N factor of these bases, you can calculate their equivalent masses. Molar mass divided by N factor. Simple. Next one is Fajans rules. A lot of times you will be getting the questions like this. Arrange the following on the base of the covalent character. Arrange the following on the base of covalent character. Remember, my dear students, covalent character, it depends on 2 things. Polarizing power of cation and polarizability of anion. Now, polarizing power of cation depends on 2 parameters. Directly proportional to charge on cation, inversely proportional to size of cation. Polarizability is directly proportional to charge on anion, directly proportional to size of anion. Remember these things. Now, for example, this is the question. First of all, this is Li positive, this is Cl negative, Na positive, Cl negative, K positive, Cl negative, Rb positive, Cl negative, Cesium positive, Cl negative. So anion everywhere is same. So I'm not going to decide on the basis of anion. I'll be deciding on the basis of cation. Now the charge on every cation is same. Charge on every cation is same. So talk in terms of size. Lesser the size of cation, more the polarizing power. And more the polarizing power of cation, more the covalent character. So this is the covalent character order here. Because the size of this cation is least. Similarly, NaCl, MgCl2, AlCl3. This is Na positive, Cl negative, right? This Mg di positive, this Al tri positive. More the charge on cation, more the polarizing power. More the charge on cation, more the polarizing power. More the polarizing power, more the covalent character. Now, remember this, CuCl, NaCl. CuCl has got more covalent character than that of NaCl. If they ask you the reason, remember in case of CuCl, you get pseudo inert gas configuration. The cation has pseudo inert gas configuration. Here the cation has got inert gas configuration. And remember, polarizing power of that cation, which has pseudo inert gas configuration, that is more. If polarizing power of cation is more, that means covalent character will be the more. Simple. So short question will be asked from this. Now, hybridization. How do we calculate hybridization? Number of sigma bonds plus number of lone pairs. Number of sigma bonds that the central atom forms, lone pairs which the central atom has. The sum of these two gives you a number called as steric number. If steric number is 2, hybridization is sp. Steric number 3, sp2, 4, sp3, and so on, right? For example, this is the water molecule. Now, for example, if I ask you about this oxygen, central atom, how many valence electrons oxygen has? 8? 8 or 6? Oxygen has got 6 valence electrons. How many surrounding atoms do you see here? 2. So number of surrounding atoms is equal to number of sigma bonds. Number of surrounding atoms is equal to number of sigma bonds. So out of 6 valence electrons, 2 valence electrons have been used by oxygen. Out of 6 valence electrons, 2 valence electrons have been used by oxygen to form 2 sigma bonds. So there will be 4 electrons left as such on oxygen in the form of 2 lone pairs. So sigma plus lone pair, 2 plus 2, 4, hybridization is going to be sp3, right? NH4 positive, nitrogen, how many valence electrons? 5. There is a positive charge, so subtract this. So 5 minus 1 is 4. If there was negative charge, you were supposed to add that, right? How many surrounding atoms? 4, that means sigma bonds are 4. 4 valence electrons, 4 sigma bonds. That means nitrogen has utilized all the 4 valence electrons to form 4 sigma bonds, right? So there'll be no lone pair on nitrogen. So 4 plus 0 is 4, hybridization is again sp3. XeF2, for example, xenon. How many valence electrons xenon has? 8. How many surrounding atoms? 2. So sigma bonds are 2. So out of 8 valence electrons, 2 have been utilized. So 6 will be there as such in the form of 3 lone pairs. So 3 plus 2 is 5. Hybridization will be sp3d. Right? This is your homework question. Do let me know in the comment section of this video, what do you think is the hybridization of phosphorus in PCl5? Moving on to one more. Moving on to one more. A relation between Kp and Kc. Remember this, Kp is equal to Kc RT raised by delta Ng. Now there are some simple questions asked in which they'll ask you, in which of the following reactions Kp is equal to Kc, in which of the following reactions Kp is not equal to Kc. Just remember one thing. Whenever delta Ng for the reaction is 0, whenever delta Ng for the reaction is 0, anything raised by 0 is 1, then I would say Kp, Kc are equal. If delta Ng is non-zero, that means Kp and Kc won't be equal. Now the point is, how do we calculate delta Ng? Delta Ng is nothing but it is number of moles of gaseous products minus number of moles of gaseous reactants. For example, this is the reaction. Calculate delta Ng for this reaction. I would say delta Ng is equal to number of moles of gaseous product. This is not the gaseous product, this is the gaseous product. How many moles? 1. Minus number of moles of gaseous reactant. There is no gaseous reactant, so delta Ng is 1. If delta Ng is 1, that means Kp, Kc won't be equal. Kp and Kc are only equal if delta Ng is equal to 0. Now look at this one. Delta Ng for this reaction. Number of moles of gaseous product, which is 2, minus number of moles of gaseous reactants, which is 1 plus 1, 2. So 2 minus 2 is 0. So I would say Kp, Kc would be equal in this particular case. Do let me know the answer of this particular question in the comment section of this particular video. What do you think? Whether Kp and Kc would be equal or not? Okay. Moving on to the 7th concept. Units of Kp and Kc. Again, a simple question. They'll give you the reaction. They'll tell you what are going to be the units of Kp, what are going to be the units of Kc. Remember, Kc units will be for a gaseous reaction. Kc units will be mole per liter raised by delta Ng. Kp units are atm raised by delta Ng. For example, if you take these questions only, they'll ask you what is the Kp unit for this particular reaction. You will write atm raised by delta Ng. That's 1. They'll ask you Kc unit. Kc is going to be mole per liter raised by delta Ng. That's 1. Right? For example, this reaction, it's delta Ng is 0. So mole per liter raised by 0. Anything raised by 0 is 1. So Kp and Kc here for this reaction will be unitless. So that particular reaction whose delta Ng is 0, your Kp, Kc becomes unitless in that particular case. Right? Similarly, you can check this one as well. Okay, moving on to the next one. pH of weak monoprotic acid. If they give you a weak acid, weak monoprotic acid, that acid which gives only one H positive, they'll ask you to calculate pH of weak acid. How do you calculate pH of weak acid? Just remember this particular formula. pH of a weak monoprotic acid is equal to half of pKa minus log C. pKa minus log C, where C is the concentration of acid. C is the concentration of acid. Ka value will be given to you in the question. And this result is only valid when alpha value is less than 0.05. Now, for example, understand. First of all, this is a weak acid. I need to calculate its pH. Ka value is given. First of all, remember, whenever I write P of Ka, P of Ka means P stands for minus log. So it means minus log of Ka. So it means minus log of 1.8 into 10 raised power minus 5. From now onwards, remember this result. Minus log of 1.8 into 10 raised power minus 5 is nothing but 4.74. Now calculate pH. pH will be equal to half of pKa value is 4.74 minus log of C. C is the concentration of acid. Concentration of acid is given to me as 10 raised power minus 1. So matter of calculation, this will be half of 4.74 log of m raised power n log m. So this becomes 1. So it is 5.74 divided by 2. This is the pH of this particular solution which you were supposed to calculate. Again, simple and basic stuff. My dear students, there can be memory-based question based on indicators. There are 4 indicators which you have to remember. Methyl orange, methyl red, phenol red, and phenolphthalein. You have to remember their color in acidic medium, you have to remember their color in basic medium, and you have to remember their working pH range as well. Anything can be asked from this particular table as the memory-based question. There is one more table from which you can get the question. There is one more table from which you can get the question. Let me tell you. There are different titrations. For example, titration of strong acid, strong base, titration of strong acid, weak base, titration of weak acid, strong base, titration of weak acid, weak base. You should first of all know in which titration, which indicator is used. For example, they'll ask you, which indicator is used when we do the titration of weak acid, strong base. You have to remember that it's phenolphthalein. Remember this. It's HPH, phenolphthalein. Phenolphthalein, okay? For example, during the titration of strong acid, weak base, which indicators are used? Methyl orange, methyl red. For example, strong acid, strong base titration, which indicators are used? You can use all indicators, right? Weak acid, weak base, phenol red. Perfect. This again a memory-based table. You have to remember it. Question can be asked from this as well. Okay. Remember, there are few points about ideal solutions. Non-ideal solutions showing positive deviation. Non-ideal solutions showing negative deviation. Remember this particular table as well. In case of ideal solution, the AA interactions are same as there of BB interactions, same as there of AB interactions. Delta V mixing 0, delta H mixing 0, delta S mixing positive, delta G mixing negative. Non-ideal solution showing positive deviation. AB interactions are weaker than expected. Number 1, delta V mixing positive, delta H mixing positive, delta S mixing positive, delta G mixing negative. Anything can be asked. Similarly, non-ideal solution showing negative deviation. AB interactions are stronger than expected. Delta V mixing negative, delta H mixing negative, delta S mixing positive, delta G mixing negative. Anything can be asked from this particular table as well. Remember this, okay? And do remember one thing. Do remember their examples as well. I forgot to write down the examples of ideal solutions here. Non-ideal showing positive, non-ideal showing negative. So just Google it once. It will just take 2 minutes. Remember their examples as well. There are 3 to 4 examples in each case here. Remember those examples. Which solution shows non-ideal deviation, which solution shows which solution is there that is basically non-ideal and at the same time shows positive deviation. Perfect. Which solution is there which is technically non-ideal showing negative deviation. So there are a few examples which you have to remember. And one more thing which I would want you guys to remember, non-ideal solutions showing positive deviations, they form minimum boiling azeotrops. Remember this point as well. Minimum boiling azeotrops. And non-ideal solutions showing negative deviation, they form maximum boiling azeotrops. Okay, this can be also asked. In which of the following solution minimum boiling azeotrops are found, maximum boiling? One more thing. Frequently you can get these sort of questions. In which of the following solutions boiling point is maximum? Which of the following solutions will show maximum boiling point? Remember, boiling point of the solution is directly proportional to the number of ions generated. NaCl, how will it dissociate? Na positive plus Cl negative. For example, BaCl2, how will it dissociate? Ba di positive plus 2 times Cl negative. AlCl3, Al tri positive plus 3 times Cl negative. Twice Al tri positive plus 3 times SO4 di negative. So more the ions generated by the solute, more the ions generated, more is going to be the boiling point of solution. So where do you think the ions generated are maximum? 3 plus 2, 5. 1 plus 3, 4. 1 plus 2, 3. 1 plus 1, 2. So this is the solution whose boiling point would be maximum. So remember, boiling point of the solution is directly proportional to number of ions generated. Okay. One more important case which I had to tell you. For example, this is the solution of A and B. This is a solution of A and B. And over here, there are vapors of A and B. There are vapors of A and B. They'll ask you, calculate the mole fraction of A in vapor phase. Calculate the mole fraction of B in vapor phase. Remember these formulas directly. Mole fraction of A in vapor phase is equal to P naught A chi A by PS. Now you must be thinking, what is chi A? Chi A is basically mole fraction of A in solution phase. In solution phase. And PS is basically the total vapor pressure of solution. Total vapor pressure of solution. And what is this chi A dash? It is the mole fraction of A in which phase? In vapor phase. In vapor phase. Perfect. A question can be directly asked from this result. Calculate the mole fraction of B in the vapor phase. P naught B chi B divided by PS. Right? P naught B chi B. What is chi B? Mole fraction of B in solution phase. PS. Total vapor pressure of solution. Chi B dash. Mole fraction of B in vapor phase. Anything can be asked from here as well. I believe this also clear. I believe this also clear. Now, my dear students, moving on to the next concept. What is that? They'll ask you to calculate enthalpy of reaction from enthalpy of formation. Enthalpy of reaction from enthalpy of formation. Remember, enthalpy of reaction is always equal to enthalpy of formation of products minus enthalpy of formation of reactants. Enthalpy of reaction is always equal to enthalpy of formation of products minus enthalpy of formation of reactants. So I have written N3 stoichiometric coefficient of C multiplied by enthalpy of formation of C plus N4 enthalpy of formation of D. So this gives you enthalpy of formation of reactants minus, enthalpy of formation of products minus enthalpy of formation of reactants, which is N1 into enthalpy of formation of A plus N2 enthalpy of formation of B. For example, this is the question. They have given you the enthalpy of formation of this, enthalpy of formation of this, enthalpy of formation of this. And they are asking us to calculate enthalpy of reaction. Now, I told you enthalpy of reaction is equal to what? First of all, is the reaction balanced? No. Balance the reaction. This should be 4, this should be 2 times, this should be 2 times, the reaction is balanced. Now, enthalpy of reaction is equal. Enthalpy of formation of product. So, start from here. Stoichiometric coefficient is 1 multiplied by enthalpy of formation of carbon dioxide, that's 50, plus stoichiometric coefficient 2, enthalpy of formation of water, 2 into 20, that is 40, minus enthalpy of formation of reactants, CH4, its stoichiometric coefficient is 1 multiplied by its enthalpy of formation. Now, this oxygen, it's in standard state. And whenever element is in standard state, its enthalpy of formation is taken as 0, right? Solve this and get the result. That's it. So remember, enthalpy of reaction is equal to enthalpy of formation of products minus enthalpy of formation of reactants. Similarly, enthalpy of reaction from enthalpy of combustion. They can give you the enthalpy of combustion of reactants and products. In the question, they can give you the enthalpy of combustion of reactants and products. You will have to calculate enthalpy of reaction. Enthalpy of reaction will be enthalpy of combustion of reactants minus enthalpy of combustion of products. N1 into enthalpy of combustion of A minus N2 into enthalpy of combustion of B. This can be one more question asked. Similarly, they can ask you the question, enthalpy of reaction, it is also equal to bond energy of reactants minus bond energy of products. Bond energy of reactants minus bond energy of products. For example, this is the question. This is the question. Bond energy of N triple bond N is given. Bond energy of H single bond H is given. And bond energy of NH bond is also given. This is the bond energy of NH bond. This is the bond energy of HH bond. This is the bond energy of N triple bond N. Now, what do we have to calculate? We have to calculate enthalpy of reaction. Enthalpy of reaction is equal to bond energy of reactants. Now, talk about reactants. Stoichiometric coefficient is 1. Right? So I'll write energy required to break N triple bond N plus this is 3 times energy required to break H single bond H. So this is your bond energy of reactants minus talk about the products. So I'll write 2 times first. Now how many NH bonds are here? In case of NH3 there are 3 NH bonds. So 3 times energy required to break NH bonds. Okay, these things will be given to you in the questions. Put the values and get the answer. Okay, they'll be given. These things will be given to you in the question. Remember that. Similarly, next point. Sometimes they'll give you certain fuels like CH4, C2H6, C3H8, and they'll give you their enthalpy of combustion values. And they'll ask you which fuel has got better efficiency, which fuel has got good quality. Remember, quality of the fuel or efficiency of the fuel, that is directly proportional to calorific value of the fuel. And how do we calculate the calorific value? Magnitude of enthalpy of combustion divided by molar mass. For example, CH4, I have to calculate its calorific value. Its calorific value will be equal to enthalpy of combustion is minus 100, take its magnitude only, so 100 divided by molar mass of CH4 is 16. So this is the calorific value of it. Similarly, this will be 200 divided by its molar mass will be 12 to 24, 24 plus 6 is 30. Similarly, you can calculate for this. And you need to check which one has got more calorific value. And more the calorific value, better the efficiency of the fuel, better the quality of the fuel. So they can give you certain fuels. They'll ask you to arrange these fuels on the basis of their quality. So more the CV value, more the calorific value, better is going to be the quality of the fuel. Similarly, calculation of empirical formula. They'll give you certain elements X and Y. Their mass percentage will be given. There is a compound. In the compound, there are 2 elements, X and Y. Their mass percentage is given. And they'll ask you to calculate empirical formula. What you have to do? First of all, you have to calculate atomic ratio. How do you calculate atomic ratio? Given percentage divided by atomic mass. So 20 divided by 2. 40 divided by its atomic mass, that's 8. So this value comes out to be 10. This value comes out to be 5. Which one is the lesser value among the two? 5. So now I'll be getting the least atomic ratio. How do we get the least atomic ratio? Divide both the numbers by the lesser one. Divide both the numbers by the lesser one. This value is 2. This value is 1. So the ratio is coming out to be 2:1. That means empirical formula will be X2Y1. X2Y1. Perfect. This is the empirical formula. So what you have to do is, first of all, divide the mass percentage with the respect to atomic masses. You'll get the atomic ratio. The one that is lesser in value, divide both of them with that lesser value. You'll get the least atomic ratio. And from least atomic ratio, what do you get? You get empirical formula. As simple as that. My dear students, similarly, identification of limiting reagent. How do we identify in a reaction which one is the limiting reagent? For example, this is the reaction that's given to me. And these are the moles of reactants that are given to me. I have to identify which one is the limiting reagent. What you have to do in short, divide the given moles by the respective stoichiometric coefficients. 5 divided by 2. Similarly, this 5 divided by 3. Which one is lesser? 5 by 3 is lesser. The one that gets the lesser value, that is the limiting reagent. Similarly, 3A plus 4B plus 5C gives D. So its moles are given. What do we have to do? Divide the given moles by the respective stoichiometric coefficient. So this 10 divided by its stoichiometric coefficient. This 10 divided by its stoichiometric coefficient. This 10 divided by its stoichiometric coefficient. The one that gets the lesser value. 10 by 5 is least among all. Right? The one that gets the lesser value. That's your limiting reagent always. Perfect. Similarly, my dear students, one more theoretical question that can be asked. That is related to that Daniell cell. Right? You need to remember, first of all, the standard EMF of the Daniell cell is 1.1 volt. In Daniell cell, you use 2 electrodes. One is zinc, one is copper. Zinc behaves like anode, at which oxidation takes place. Copper behaves as cathode, at which reduction takes place. The direction of electrons is from anode to cathode. The direction of current is from cathode to anode. Thickness of zinc rod decreases with time. Thickness of copper rod increases with time. And this is the net reaction that takes place in the Daniell cell. And remember, N value in case of Daniell cell is 2. That means number of moles of electrons exchanged in the Daniell cell, that's equal to 2. So these were some easy kill 20 concepts, my dear students, out of which anything can be asked. Okay, I hope you like this session. I'll be sharing the PDF of this particular session in my Telegram. The name of the Telegram channel is Wassim Bhat Chemistry Official. The name of the Telegram channel is Wassim Bhat Chemistry Official. This is the name of the Telegram channel on which I shall be sharing the handwritten PDF of this particular session. And at the same time, my dear students, tomorrow at 10 a.m. do not forget to join me live on this particular channel, because I'll be doing some top 180 questions of chemistry from which I will tell you 25 to 30 questions directly will be asked in your NEET examination for sure. So tomorrow 10 a.m. do join that particular session. That session is already public. You can check in the live category. Do smash the like button right now so that you'll be updated about this particular session. With this, take a leave. You take care. God bless you all and love you all, my dear students. Bye-bye. God bless you all.